Good evening, everyone. I am Nikhil, and we are from Group 20. Me, along with my friends Ashika and Prajwal, today we are going to present a paper which is based on recommending users in social networks by integrating local and global reputation. Coming to the introduction, a central research theme in online social network scenario consists of predicting the trustworthiness of a user should assign to the other online social network members. The past modules are global reputation dependent, in which users should rely on the other user's feedback, which is not entirely reliable and also not entirely trustworthy. In this paper, author introduced a more reliable model which integrates the global reputation model to the local reputation model. A relevant research issue in OSMs is that to design systems that are capable to provide a user with suggestions about their trustworthiness, to assign to other users with which he or she has not interacted in the past, which helps users to avoid unreliable information and also to avoid harmful interactions with others. For example, online social networks like ePinions and CIAO and other which allows users to create accounts and share information and feedback on a lot of things from which user can take advantage of other users in order to evaluate the probable trustworthiness of an interlocutor. For instance, in CIAO and ePinions, users can post a review that can be evaluated by others users. Such a form of reputation will be called global reputation, which is achieved by feedbacks and reviews of an entire community. Global reputation has been largely used in the past systems for online social networks, but its effectiveness in estimating trustworthiness of unknown users is limited by the uncertainty due to reliability of the recommendations. The authors evaluated their model on dataset extracted from the social network CIAO obtained two main results, which are the role of global reputation is relevant only for those users having an ego network small enough. The use of sole local reputation is the best choice for minimizing the average error in predicting the trust with respect to consider all the users of the online social network. This paper is organized in the following manner. In the section 2, they illustrated some related work. In the section 3, they synthetically described the scenario which they dealt with. In the section 4, they present the approach in which they proposed for predicting the trust of a user in another user. In section 5, they described some experiments which they performed for evaluating that proposal, and finally in the section 3, they concluded the paper. Coming to the related work, in OSN trust systems, the three main aspects are identifiable in informative sources, aggregation rules, trust inference, along with the social networks. The information sources at disposal of a user are the direct opinions derived by the own personal and past experiences, and the indirect information consisting of opinions provided by the other users. They are known as the reliability and the reputation of a user. In an online social network scenario, reputation is often predominant since a user usually interacts with a narrow portion of affiliated and therefore a trustworthy opinion about someone could be difficult to obtain without to rely on opinions provided by the others. If we model an OSN as a directed graph, trust, net, trust network whose vertices are users and the edges encode the trust relationships, we can use some topological concepts from graph theory, like the concept of path or the concept of shortest path, to infer trust relationship among pairs of unknown users. The trust algorithm, which is another algorithm, infers trust values in the trust networks. In tidal trust, trust values are continuous values in a fixed interval. Tidal trust performs a modified breadth first search on the trust network to find all the shortest path linking two users which are not directly connected in an incremental way and computing the user's trust rating as weighted average of trust rating from the source to the target users. The mole trust, which is another way which helps in computing the trust score of all the users at each depth in the path between two users. In particular, the trust score of a user at depth x only depends on the trust score of the users at depth x minus 1. The predictor user's trust values consider the average of all incoming trust edges from users having a predicted trust score greater than a threshold, the trust score greater than the user who issued the trust statement. Jamali and Lester proposed a random trust walk model called Trust Walker, which considers both ratings of the target items and similar items. The random walkers searches in the trust network, while the other components considering ratings on the similar items to limit depth search in the network. Trust Walker improves the precision by preferring raters at the nearer distance and improves the coverage by considering similar items as well as the exact target item. The section 3 will be explained by Ashika.
So I'll be talking more about the scenario they created to evaluate their approach. So first, they create an ego network which consists of the closed network of a user. So these are the description of some of the variables we'll be using throughout the presentation. So S stands for the social network. U is the set of users that are there in that particular ego network, and the graph G is a directed graph because it does not imply that B also trusts A if A trusts B, so it has to be a directed graph. And we say a node between users exists if A trusts B, so there'll be an arc from A to B in that case. And every node U will be corresponding to a user. So N of U basically represents user U. So next we talk about the graph represented by T comma P. So T represents set of all the users either directly or indirectly trusting a node U, and P is the paths between the node N of U to all possible N of K nodes. And LT depicts the local trust. So to explain indirect trust better, so if there exists a node K such that U directly trusts K and K in turn directly trusts V, then we can also infer that U indirectly trusts V. So next, the local trust that we talked about. So we define a node V belongs to the network of U if there is either direct or indirect trust between the pair of node U and V. And if there is this pair, then we assign the reputation measure lambda by measuring how trustful the relationship is between U and V. And every contribution of the contribution of every node in that ego network will be summed up after individually evaluating those links. And once we have this, based on these pairs of nodes, we form a local network considering these contributions. And once we have this network, we can quantify their trustworthiness. So if there is a direct link between nodes U and K, we can say that their contribution is 1. And in cases where there is indirect trust between the nodes, we can evaluate their contribution through this formula, where L of u comma k here represents the distance between u and k in the network. Since they're not directly connected, we have to calculate the distance between them and substitute those values in this particular formula and obtain their contribution. So this penalizes, so the farther the node k is from u, lesser is its contribution. So the exponential factor tries to penalize the farther away nodes. So in this way, we form a local network by assigning more value to the nodes that are closer to the one which we are evaluating, which is node u. So then what the authors did is they normalized this particular lambda value by summing them up for every possible combination of u and v and dividing it by their maximum value. And so this is the final formula for local reputation. So next, to also consider the global reputation, they considered the metric as feedback. So for a set of actions performed by a particular user u, we we evaluate their trustworthiness based on the feedback they have received from other users. Say for example, we can say the like and dislike feature of YouTube videos, and also the comments on a particular video can be analyzed to be positive or negative by sentiment analysis. And the authors derived this formula wherein they wherein they calculate the average of all the feedbacks for all the particular users in a particular network. So since this is a global measure, all the users in the network are taken into consideration. So first they assign synthetic scores for each pair of node u comma v, and this is given by the following formula here, where the local reputation lambda and the global reputation gamma are summed up, and the weight parameter w, that basically decides how much weight should be given to a local reputation and how much to value the global reputation of a particular network. So this is the formula, and how they decide whether to say that you trust v or not. They set up a threshold value, and if this sigma value is greater than a threshold, then we say that you trust v. Otherwise, we say it's a not trustworthy network. And once we have this metric set, we take up a training set, basically consisting of the users, the actions they perform, the feedback they received, and the trust between them. Next, what we do is we set an initial values to w and tau, which is the threshold, and we calculate the trust based on the formula that we saw in the previous slide. And then what we do is we calculate the absolute difference between our calculated trust and the actual trust. And if the difference is greater, we discard those initial weight and threshold values, and we basically iterate through the process and come up with the values for w and tau such that the difference is minimal. So that is the whole aim of their approach. So they calculate the average for all the users, the difference of trust for each pair of node, and then they try to reduce this cost by choosing the appropriate values for weight and threshold. So this is the approach they suggest. I'll now pass it on to my groupmate Prajwal to talk more about the experiments they conducted and also conclude the presentation. Thank you.
Thank you, Ashika. I'll be discussing about the experiments that were conducted to validate those approaches that were discussed earlier. Here, the authors used the real data extracted from well-known CIO social network, which is publicly available. Firstly, they have examined how the global error depends on the mean of the user U. As you can see in the above figure 2 and 3, the error E is reported for different values of the weight and threshold T, and for 4 users having different values of the network density. Here, we can observe that for all the users, the error generally decreases with the threshold parameter T, obtaining the best results in the correspondence of threshold T is equal to 0.6. For values of threshold T higher than 0.6, the error increases. Thus, the authors have only represents the curves corresponding to some values of threshold T greater than 0.6. Now you can also note that the user with ID equal to 101 having a relatively small value of density rho equal to 733 represents an error that has a minimum in correspondence of the pair weight and threshold equal to 0.5 and 0.6 respectively. Therefore, for this type of user, merging both local and global reputation is in equal measure is important due to the fact that the local ego network is not large enough to suggest a correct trust without the help of the global reputation. But the user with ID equal to 1 having the network density rho equal to 2560 again represents the minimum error in 0.5 weight and threshold is equal to 0.6, but the difference from using high values of weight is less important. Now coming to the figure 3a and b, the figures 3a and b are related with users having very high values of network density rho, and it shows that the influence of the global reputation is almost negligible. Next, the result reported in the figure 4 is finally related to the entire CIO dataset and represents the global error averaged on all 2600 users composing the dataset. This result shows that for obtaining the minimum average error for the entire community, it is possible also to use weight is equal to 1, avoiding to consider the global trust. Now coming to the conclusion part, this paper proposed a model mainly for integrating local and global reputation in an online social network. Here, 3 important parameters were considered characterizing the model. First one was weight, threshold, and network density. Here, the weight represents the importance given to local and global reputation. Threshold is the reputation, the threshold under which a user is considered unreliable. Network density represents the dimension of the user ego network containing all the online social network members connected to him or her via path of trusted links. Some experiments on a real dataset extracted from the social network CIO showed that the size of the user ego network has a discriminatory effect. In fact, global reputation is relevant only for those users having an ego network small enough, but in case of users having larger ego network, local reputation is sufficient for predicting trustworthiness with a very high precision. Besides, this experiment shows that the use of the sole local reputation is the best choice to minimize the average error in predicting the trust by considering all the users of the online social network. They argue that these results are particularly important in designing a recommender system for online social network, having a larger ego network for most of the users. Since in this case, we can avoid to use a global reputation mechanism as usually implemented by many of the online social network. Also, the author suggests that they will further enhance their approach by considering the various characteristics of the ego network. And this is all about this paper, and thank you everyone.